Okay. So I think I found out why my streams kept on crashing. So I believe that it was actually an issue with my computer in Python, is my guess, because I'm writing so much data to the file that easily something is going wrong. Because every time I exit the program, that's when my computer would crash. I thought it was when I showed the 4 different scenes, but I actually think that that's not the case. Okay, so my stream is back up and running. Please forgive me for that interruption, but we didn't lose anything, so we got it. I had to start a new stream, but we got it. So this is what, yeah, perfect. So this is what it looks like. Is we're getting these arrays with dictionaries inside of them, and the dictionaries contain all of the data we need. So the first thing is a date time object. Let me find one with 2. Yeah, here we go. Here's one with 2. So the first item is a dictionary. Nope, it's not. Well, oh, here. Well, that's interesting. How in the heck did that happen? Yeah, they each are separate. I don't see. This one looks like it has. You can see it's off the screen. This one looks like it has 2. It does. It does. So this object has 2, and it has the date time. So it's awesome. So we pretty much are looking good. So the data was captured. The reason my computer crashed was because I didn't write the program properly, which is kind of hilarious that Python can crash your computer if run improperly. That's just a guess. But anyways, so now what we see here is all the data from the capture. So I'm going to close this, and I'm going to copy and paste this, and we're going to name it uMyo. I'm going to underscore capture, and today is 9/13. 9/13/2023. Okay, and then we're going to copy and paste this one. And this one is going to be lask4 capture 9/13/2023. So these two are right now ready to go. And I'm making new folder 9/13/2023 backup. Doing this just in case, because I really do not want to lose one of these data sets, because one of these data sets can be used to train a neural network or artificial neural network or machine learning algorithm or machine learning model. There's so many names for the same thing. They're not necessarily the same. I'm just trying to get used to all the terms. Okay. So, where is my filter? Okay, here's my packet filter. So we're going to just play around in this folder inside of uMyo tools, and let me open up GitHub real quick and put that link in chat. And let me open up GitHub desktop and push these changes. This is going to be 9/13/2023 live stream. And uMyo tools, push origin. Okay. And my repositories, now I can put this in chat. But this is exciting. Okay, so this, before I couldn't just filter the data because the data was not organized too well, but now it's organized well. And I'll show you what I mean by that. Okay, sorry for doing things off screen. But let's go ahead and open the packet filter. So now we're going to have to work on getting the data out of the packets. See, I was doing this stupid stuff. I'm just going to delete everything here and run this. So if we run this, yeah, it's not going to see the file names, which is fine. So F2, Control A, Control Copy, uMyo. Just pasting the text. F2, mother fudger. I didn't say a cuss word. I almost did. Lask. Here we go. Okay. So let's run this module, and what it will do is it treats the data from both of those files as just lines, like in a paragraph. And so if there's a line break, it just separates them. So what we're looking at is a plain text of the first items, the first elements in both of the files. So that is really cool. And I'm probably just going to copy this, and this is going to be sample packet, and we're going to do three quotations. So that way, just in case I need to reference the packets, I can do so inside the file, although, whatever. Okay, let me see if I can shrink this. Is it big enough on the screen? Okay, it's decent enough on the screen. Okay, so we're printing both. Now what we need to do is we need to come up with our algorithm. And I will do that interestingly. And I think this is why I've had success on using a regression model, is because I'm trying to give the regression model the data it needs. And I don't care about I care a lot about the formatting, but it's kind of hard for me to explain this. So I'm going to make a diagram here. Okay. So I'll show you what we kind of need to do. So what we have is kind of like a block of information. And we're going to say this is data set with timestamp. So one of the most important pieces of this data is that it has a timestamp. And we'll just put, what is the clock emoji? Clock emoji. Alarm clock emoji. Sure, why not? Oh, yeah. And I need a font that can actually read it. And nope. Emoji 1. There we go. Actually, I want the black and white, which is this one. There we go. Okay. So this is our timestamp. And it's unique to this block, right? So this is, for example, going to be uMyo. And let's pick a good font. ITC Avant-Garde. There we go. That looks somewhat nicer. So we have uMyo. And inside uMyo, we have XYZ. We have QGS, EMG, and then compass. Okay. I have to say things out loud in order to. So that's what uMyo has. Okay. So it has a timestamp and it has those elements. We are going to have 4 of these. So 1, 2, 3, 4, whatever. Gonna have to make it this wide landscape. 792 and then 8.5. Okay. So there we go. So we got the uMyos, and then we are going to have the LASK system. So LASK 4, and it just has 4 labels. And it's just going to be, it is just Hall effect, Hall, 4 Hall sensors. There we go. And it has a timestamp. So I'm kind of collecting my thoughts in this diagram. And I'm going to move the uMyos, not... Okay. Okay, so the amount of data that we have, the uMyos, the XYZ is 3 numbers, is 3 columns. QGS is 4 columns. EMG is 8 columns. And then Compass, I don't know what that is. I'm assuming it's just 1 column. So let's just say that we have all those data sets, 7, 8, so it's 16. So 16 per one. And then the LASK just has, plus time domain. 16 sensor datas, 1 timestamp. Okay, and this is for each uMyo. So what we're going to have is 17 times 4, which that's going to be crazy. So plus the 5 from the LASK. The reason I'm trying to identify this information is this is the format that we're going to need it in for machine learning. Come on, come on. Do what I think, not what I say. So in machine learning, you got, at least for supervised machine learning, you have the feature data and then the label data. So the feature data and then we got the label data. Okay. So the label data and the feature data, they're going to have a timestamp, and I'm going to represent that by the black bar. The black bar is the time data that's going in. There's a reason I have the time domain inside of there, because it is very much a part of the data. And actually, the machine, the model is going to predict time, even though I throw out the information. So we have 1, 2, 3, and then 4. I'll make these equidistant. Okay, so we got the feature data. This is not very helpful. Let's make the time domain yellow, because I usually have SCL pin as yellow. And I just so happen to put that line. Okay. So what I'm going to have is I'm going to have a whole bunch of data, then a timestamp, whole bunch of data, timestamp, whole bunch of data, timestamp. And these times are not necessarily going to add up. And you might think that's kind of silly, and why am I doing that? But it was the best success that I had with doing machine learning for OpenMuscle. So I'm trying to replicate just the same process. So the label data is going to have 4 Hall sensors plus the time. So there's going to be 5 over on this side that we're teaching the model what the output is. And since we only have 4 fingers that are actually, or 4 movements that we're trying to learn, that's all it's going to be sending out. Plus, it's going to predict the time, but we won't get into that. So I think what we're doing, I think I'm just going to ditch the EMG data for now and just go with the QGS, which is built into the uMyo, and it does a little bit of filtering for us. And I think that is the easiest. So I'm going to have to build the header of the packet. Sorry, I'm going to have to build the header of the CSV file. So let me open up my open muscle stuff here. Documents. Sorry for this boring stream, guys. Open muscle. Okay, demo. I think that's where it was at. I think it's inside of data captures. Yeah. So it's open with Python. So as you can see in the sensor filter that I had before, I'm ending up with making the right. Actually, you know what? Copy, paste. I'm gonna put this inside of packet filter. Okay, I'm gonna go down and paste it. There we go. So many windows open. Sensor data filter. All right. So we'll probably do a very similar thing, but we're gonna have to line up 2 different files. So this is interesting. I think I'm gonna have to turn them into. So I have the send chunk and then check chunk, which is fine. Okay, so text file equals capture 11. So this is 2 different files. So we'll do last text file, uMyo text file, okay. And I cannot spell today. Okay, so it's going to open up these files. uMyo text file. And CSV is going to be, we're just going to call it September 13, 2023. So this is going to be fun. We first want to write the row here, and this is going to be our header. So so the object, I end up putting the OM time at the end, but this time I think I'm going to put it at the beginning. So we're going to have date time, or this will be uMyo 1 time. So this will probably not make any sense to you guys. But what I have to do is set up the format that I'm going to have these packets be filtered into. And I need them to be all the way across, so this is going to be quite a bit. So uMyo 1 time. Just going to call it U1 time. And then this is going to be U1 QGS 0. to start with 0, QGS 0. Now 4 of these. QGS 0, QGS 1, QGS 2, QGS 3. Then we also need the XYZ. So we're going to do U0X, U0Y, U0Z. Okay, awesome. So we'll have 4 of these. And of course I have to replace all these numbers. I could probably do this in Vim or something, but it helps me kind of think while I'm doing this. Probably I'm also going to make a mistake, but what's programming if you're not making mistakes? So I have to have one row have all the data that I'm sending. What's also interesting is I can't talk and do this. Okay, so we have those 4. So now we're going to have the last, and those are going to be the same. Luckily, we can just get it entered here. 1, 2, 1, 2, 3, 4, and then last. Okay. Right or right row. Boom. Bob's our uncle. Okay. So this is the header for the CSV file that we're creating. And we're creating a CSV file because that's what we're going to use to train the scikit-learn random forest regressor. So how I did it before is kind of have a chunk in a bucket. So if you can imagine like the data coming in to this bucket. So I'm going to stream the data in, throw it into this bucket. And while it's falling in, I'm going to do checks to see if there's timestamps that match up the packets as close as possible. And if so, send it to the model, right? Send it to the CSV file. So that will get removed from this bucket's temporary memory. And as they're coming in, if a packet gets too old and comes to the top and doesn't find a match, it's just going to go off into nothingness, and I'm going to disregard the packet entirely. I pretend like it doesn't exist. And by doing this, I find the closest matching time-stamped values. But when I send this into the model, I don't just send it as if it's rounding off the time. I'm sending it with the timestamp. So it's kind of funny. It's like you're sending random packets in the stock market exchange to AI, and it's trying to reconcile what it thinks for the impetus for the change, but it's not nearly as complicated because there's not nearly as many variables. And since so the input and output is directly correlated in many ways, just a way that's too complicated, it's too multidimensional for even me or a lot of people to look at. That's what AI is good at, or machine learning. It's pretty much doing statistics analysis of the data in real time. So since we're not just giving it a blanket packets without a time domain, we're giving it the time domain, and actually it's a variable it's trying to predict. So it's actually going to be trying to predict the time that the LASK actually captures as well, which is kind of funny. And it might bite me in the butt later, but I really it has worked. So okay, so we're going to have to match these pairs. So for I in text read, split n. Oh. So it's going to do j eval. Okay, so it's going to eval each one. And see, this is kind of doing it in real time. That's probably why I did it this way. One of the other things that's kind of a pain is that I'm trying to do this in a way that would be able to be done in real time, but I don't know if I'm going to be able to try that in the first. No, this one wasn't. Okay, that's right. There's another one that is live. So match pairs, Brian text read split. Well, I'm going to run into a problem here. Hmm. I'm going to have to open both of those up, and they aren't matched. Hmm. Well, this is a predicament. So I have two different files instead of one. Hmm. Well, I might have to take a pause. I'm going to take a break. I'm going to stop streaming because now that I at least have the header of this, I'm going to try to figure out the best way of breaking them apart. So what we got accomplished today, let me just go over this, is we got some of the code in the data acquisition working so that when the uMyo captures data, we're putting it in a dictionary format that's inside of an array. And those are, yeah, that's pretty cool. And so it's a little bit easier to access. And not only are we giving some of the data, but we're also getting the EMG data. So we're getting the QGS data, the EMG data, the accelerometer, and I don't think I'm getting the compass, which I probably should get the compass too. But now that it's in a close to done format, I can at least try to make the algorithm that sorts these and puts them together. And I don't know how I'm going to do that yet because I want to design this in a way that can be done in real time. But I'm not going to try to put too much stress on myself to make it real time, but just able to be adjusted to be in real time. Because I'm going to have to do that next to actually predict which finger movements I'm doing. So it's one thing to train the model, but we're also going to try to predict it in real time and see the speed, run some tests on it. So let me pause, or not pause, I'm just going to stop the stream. I'm going to work on that algorithm. I'm going to post these values. I'm going to post these values into the Discord server to let people know what I'm doing, and then check back later. So thanks again for everyone that's helping, and just a shout out. Hey, how's it going? Just a shout out to Ultimate Robotics for making these awesome products. And we're getting close to machine learning, so I'll come back. I do have to leave. I was just finishing up, so hopefully I'll have some more soon. But I am going to put all these things on Discord. So till next time, guys. Let's see if we can make positive. Let's see if we can make a